Okay, here's our topic 6, application. So we're just going to look at the word problems and figure out what we need to know. Number 50, the dimensions of a rectangle can be represented by the expressions x plus 7 and x minus 3. The area is 75 square feet, and they need to know the value of x. So really we just need to set up an area problem that says, well, if I take the length times the width, it will equal 75. So remember, what we need to do is we actually need to distribute this and get the 75 over. So we're going to go ahead and distribute first here. I'm going to have x squared. Now 7x. Then I would have, and the negative 3x here, minus 21 equals 75. Still simplifying. X squared plus 4x minus 21 equals 75. I'm going to go ahead and pull the 75 over now by subtracting it. So what I'm going to have is x squared plus 4x minus, well, it's like 96. Finally, equals 0. Okay, now we can factor. So I'm going to pull it back up here so it's kind of out of the way. Is there anything that will multiply to 96 that will add to 4? And the answer to that is yes. That's actually 12 feet there, so it's going to be 12 times 8 feet there, so 12 times 8. So let's go ahead and set that up. Let's say plus 12 and minus 8. Let's tee it up. So this would be x equals negative 12, and this would be x equals 8. Now in word problems, we don't just get numbers. They have to make sense. So I want to find the value of x. Now remember, this is a rectangle. And this is x plus 7, and this is x minus 3. So if I put in a negative 12 for x, the side length would be negative 5, and that's really not going to work. So it would have to be the 8. So I believe that it's going to be 8, I should say. 8 plus 7 is 15, and 8 minus 3 is 5, and 15 times 5 does equal 75. So yes, x does equal 8. There's my final answer. Now number 51. The stress distribution on a structure is given by S equals 2x squared plus 4x minus 30, where S is the stress in pounds per square inch and x is the distance in feet from a reference point. At what distance is the stress equal to 0 pounds per square inch? Okay, so we want 0 pounds per square inch. So really, we just want to set this equal to 0 and do what we already know how to do. We're going to end up factoring. So let's do that. 2x squared plus 4x minus 30. They told us they want the stress, which they even give us the letter S. They want it to equal 0. So we need to factor out if we can. I know I could take a 2 out. So x squared plus 2x minus 15. Do I have values that multiply to negative 15 and add to 2? I do have 5 and 3. So let's do that. Positive 5, right? Because the 2 is positive. So then I could tee each of these up, and I would know that this would be x equals negative 5, and this would be x equals 3 when I set them equal to 0. And then I think about distance, and I know that negative 5 doesn't make sense in distance. Positive 3 does, so my answer here for x would be 3 feet, would be my distance. All right, we have one more. A toy rocket, oh, I love these, launched, remember gravity's here. A toy rocket is launched from a platform that is 48 feet high. The rocket's height above the ground is modeled by the equation. They usually will give you the equation. What is the rocket's height at 2 seconds? So they want to know h, I don't know, but they told me t, 2 seconds, time. So if I know t, I need to go find h. So let's plug t in. So h equals negative 16. Instead of t, I'm going to write 2 squared plus 32 times 2 plus 48. Order of operations is important here. This would be negative 16. 2 squared is times 4 here. Okay, and now we can do some multiplication. So negative 16 times 4 is negative 64. 32 times 2 is also 64, plus 48. So my height would actually just be, my height's going to be 48. Are we in feet? Yeah, it's going to be 48 feet. So at 2 seconds, it's going to be at 42. So it's going to go up, and in 2 seconds, it's going to be right back down to the same height as the platform. So if you think about it, they're launching it up. So it's starting at 48 feet on the platform, right? They're launching it up in the air, and in 2 seconds time, it's going to be at the same height. So if you were looking straight out from the platform, that's when it would start coming back down. Lower than the platform, I should say.